Okay, so today we're gonna do volume, but instead of the washer method, we're going to use the disk method. As you can see here in our formulas, one is just where we factored out pi. Since it's a constant, we can pull it in front of the integral. But in this one, it's just that pi r squared times dx. The dx has to be there in order to integrate. And so you may be thinking, okay, this is simpler than what we have been doing. If you're understanding a washer method, then you can definitely get the disk method. So it's just basically the area of the square times the thickness of that disk. A disk is kind of like a frisbee or anything where there isn't a hole, it's just rather a circle. So let's get to our first problem where we get to draw just this, and that's it. Okay, so as you can see here, I have our first example. I left up that equation so you can use it as a formula. If you didn't write it down, make sure that you do. Either one is fine. So in our examples, is to find the volume of the solid generated by revolving the region. So it's very similar to the other problems. It's talking about volume and it being created by revolving some sort of region about some line. So each problem is different, and this particular problem is going to be revolves about the x-axis. We'll get to that later. So the region itself is going to be bounded by the lines x equals 2, y equals 0, and a curve y equals x squared. So make sure that you shade in the correct region that you're going to revolve around. Okay, so I want to move this around so that I have enough room for us to start our problem. So we're going to start off by sketching this out, and we will need the coordinate plane. This is supposed to be a straight line. Let me try this again. Okay, much better. So we have our coordinate plane. Let's see what we want to go up by. So since we need the line x equals 2, then I need at least up to 2 on our x-axis. So I'll go to -2 here. This is going to help when, or if we needed to reflect it through the y-axis. So it's also important if I'm going to have the equation y equals x squared plotted, I should probably go up to 4 on here on my y-axis, which means I'll go down to -4. Again, this will help when we have to reflect our region if it's about the x-axis, which for this case it is. Okay, so let's continue. Let's put in our lines. X equals 2. And let's put in y equals 0. That's our other line. It's actually the x-axis. Okay, I want to put in different colors so we can see what we're working with. And our curve y equals x squared. So hopefully we can kind of get that in there the correct way. And I'm kind of doing a very thorough job. So now we can see where these 3 colors kind of cross, and it's over here. This is the region that's going to be revolving around the x-axis. And you're going to see that as you shade this in, maybe you can see it in mine, but as you shade this in, there's no hole, there's no gap as there were with like a washer, okay? So as this revolves around, let's say to the other side here, it becomes one solid piece, okay? And that's important to understand why this is going to be using the disk method. So as we start to draw in a cross-section, vertical cross-section, it's going to be a circle with a radius measuring this way from our curve, okay, depending on where you're drawing your circle. Maybe it's over here. but it's still from the curve down to our x-axis. So if you're revolving it around a horizontal line, remember top minus bottom. If you're revolving it around a vertical line, remember right minus left. And you only need it once for our radius. So let's talk about that one-time radius. R equals. R is going to be a function of x because we're revolving it around a horizontal line like the x-axis. So top minus bottom we already discussed. It's going to be x squared minus, and the bottom is where y is equal to 0. So we're using the x squared minus 0. Okay, it is a function of x. It is x squared. And we do this just in case it's not revolved around the x-axis. Let's say it revolves around a different line and you're subtracting 1. Okay, so do be careful of that. So let's move on. V sub x, because everything's in terms of x. We can factor out the pi, we can leave it in, doesn't matter. We're going to have pi r squared. We're going to integrate with respect to x and x values. Okay, so where does our region start and end in regards to the x values? So I don't know if you can see on my graph, but definitely on yours, in your notebooks, it should start when x is equal to 0 and end when x is equal to 2. So those are the values that we're going to put there. And I'm really running out of space to actually evaluate this, but I think we should be okay. So let's see, v sub x is going to be pi times the integral of x to the 4th with respect to x from 0 to 2. I don't have space to write x equals, but that's okay. Next step. So v sub x is going to be pi times x to the 5th over 5. And we're going to plug in 2 and 0. Next step, v sub x, we're going to plug in that 2 and 0. Subtract. And so we end up with our answer. So we end up with the volume being 32 pi over 5. Okay? And that's that, just by the disk method. Okay, so keep in mind some of the things that we have been doing before. Nothing's really changed, but that we're just looking at a disk. There's no holes, so no washers needed. Okay, good luck.